Welcome to a lesson with Dr. Powell. Let's talk about what it means for a function to preserve structure. Well, what kind of structure? Suppose we have an arrow structure and maybe a statement that there exists an arrow from A to B. And perhaps our function starts out in a set of elements that have some arrows between them, and some elements don't have arrows between them, but some do. So let's take a function f, and it's starting from a domain set going to C. And in C, you have these elements A and B are located in this set D, but in this D, we add some structure to it. In particular, we add some arrows. So suppose that there exists an arrow between A and B, that if the function f transfers structure or preserves structure, then this is what f is going to do. It's going to output f of A and f of B, and an arrow is also going to be transferred. So the whole structure is transferred. So this whole thing, diagram AB, is transferred to a diagram over here. We're taking the image of the arrow, image of the A and the image of B, and we're going to say, and this statement, there exists, is also true. So the function preserves a structure if this statement turns into this statement. There exists an arrow from A to B, turns into there exists an arrow from f of A to f of B. And all the arrows in the image of f are going to be of the form, well, an image arrow. So that just means the arrow that this arrow is sent to. So arrows are sent places and elements are sent to places. So this is one example of what it means for a function to preserve structure. Okay. For instance, what if we had D as being something like this: 1, 2, 3, and maybe C looks like this, and maybe make this 2 or something like that. So, well, naturally, what if we send 1 and 2 and 3 all to 2, and let's send this arrow and that arrow to that arrow, so every arrow has an image. This definitely preserves structure because there is an arrow from 2 to 2, and you can think of this arrow as being the image of maybe the arrow from 2 to 3, and 2 ends up being the image of both 2 and 3. So really, this is 2, this is 2, and this image arrow is just that loop right there. Okay, now also another example of a function preserving structure. What if you have addition structure? So an addition statement usually involves adding and then what it's equal to. So suppose you start with a function that you have A plus B is equal to C. So this is a statement, just like we had a statement before of there exists this arrow and there exists something in the image. Well, here we're going to just have like this is that. So we have the whole statement. What is f going to do to that particular structure, that addition structure? F is going to send it to, if it preserves structure, it'll send it to something like this, where this is the image of the addition over here. So in other words, if you're adding over here, it'll be equivalent to whatever the addition is in the image or the codomain. So whatever the addition is in the codomain will work in the same way, so that in the codomain, if you add f of A and f of B in the codomain, you'll get f of C in the codomain. And in the domain, you had A plus B is equal to C. So that's what it means for a function to preserve an operation, such as addition. A nice example for this would be in modular arithmetic, where Suppose we have something like 3 plus 1 is equal to 4. And suppose that we reduce, so we have a function that reduces mod 2. That essentially means that you send a number to the idea of either odd or even. And if it's odd, you say you output 1. If it's even, you output 0. And maybe we put a bar over this, a bar over that. So 0 bar will represent even numbers, 1 bar can represent odd numbers. So we think about this, mod 2, let's see what happens. We reduce everything mod 2, meaning we just call it odd or even. So this becomes or 0 bar or 1 bar. So this will become 1 bar plus 1 bar. Now we're going to think of plus as being between odds and evens if we have an addition between odds and evens. So we have odd plus odd, and the statement is, so if structure is preserved, let's see what we get. So this is going to be even, so 0 bar. And is it true? Well, mod 2 arithmetic means yes, is a relationship between odds and evens, and odd plus odd, an odd number plus an odd number is always an even number. Yes, so it works. So the addition structure was successfully transferred in this particular case. Thanks for watching.